All right, continuing with our proofs here, I'm up to assignment 2.5, number 7. So here again we're proving a property. So remember, you can't use the property to prove the property, and this is kind of a weird property since it's so obvious. Kind of trying to figure out where to start. In this case, I'm going to start with the EF, length EF equals length EF. This is something I can always say, a number equals a number, and that's because of the reflexive property of equality. Okay, remember, I can't use the reflexive property of congruence, but I can use the reflexive property of equality. So this is a true statement. And from this, so if these two lengths are equal, then I can say that the segments are equal and are congruent, and that's because of the definition of congruent segments. So an unusual proof, but a short one. And let's go ahead and then prove the transitive property of equality, or of segment congruence. So again, I'm proving a property or a theorem, so I can't use this property or theorem. And here they talk about AB is congruent to JK, and JK and ST are, so all three of these are congruent. And normally you'd be able to just make the jump and say AB is congruent to ST, which is what we want to prove, but this time we can't. In the past we've been converting these to numbers, so we'll see if that strategy works this time. So segment AB is congruent to segment JK, and segment JK is congruent to segment ST. And this is given. Length AB is equal to length JK, and length JK is equal to length ST because of the definition of congruent segments. And so if these are equal, now I can use, since it's equality, I can say that the length AB equals the length ST. If A is equal to B, then B is equal to C. That's an example of the transitive property of equality. Notice, of equality, not of congruence, so it's okay to use it. And if I can say those two segments have that same length, then just like our last problem, I can say that they're congruent, and that's the definition, definition of congruent segments. Okay, let's try number 9. Okay, here we're starting back with our algebraic problems. So, looks like they're saying that segment AB and BC are congruent, and here it says CD and BC are congruent. So it looks like all three of these are congruent, and looks like the length of this segment and this segment are equal, so I could set up an equality and hopefully solve for x. So let's go ahead and do that. AB is congruent to BC, and CD is congruent to BC. That's given. And because of that, the transitive property, if A is congruent to B and B is congruent to C, segment AB must be congruent to segment CD. Of course, I want these two because these are the two I'd like to set equal to each other. So this is the transitive property of congruence. This is the definition of congruent segments. And then I want to substitute in these two algebraic expressions for this. Sometimes, some people say AB equals this. You don't have to do that. If it's expressly given in the diagram, I'll let you just go ahead and substitute in. So in this case, 2x plus 1 equals 4x minus 11. And that'll just be the substitution property of equality. Okay, let's start moving things around. Negative 2x plus 1 equals negative 11. I like the x's on the left right from the start, so I'll subtract rather than add. And that'll be the subtraction property of equality. Notice, keep these two straight, so write a little extra out there for substitution. And let's subtract 1 from both sides. And that's also the subtraction property of equality. We'll divide both sides by negative 2. And that's the division property of equality. Since this is an algebraic portion, go ahead and check that. So 2 times 6 is 12, plus 1, and 4 times 6 is 24, minus 11, so this is 13 equals, yep, 13, so that checks. I'll label this part of my work, and again, now I don't have to miss that problem. Get up to number 10, looks like another segment problem, and they tell us that the entire length here is 46, and they tell us PQ is this and QR is that. Alright, so these must add together to give me 46. Let's start with my given. Length PR equals 46. Somehow I've got to get these added together. So we know that the length of PR equals the length of PQ plus the length of QR. If that's the given, then this is the segment addition postulate. Everything else is substitution. I can substitute in 46. I can substitute in these two algebraic values. So let's see what that gives us. 46 equals 2x plus 5 plus 6x minus 15. Okay? And that's just a substitution property of equality. And now we just put things together. 46 equals 8x minus 10. That's just combining like terms. We'll add 10 to both sides. And that's just the addition property of equality. Divide by 8. And let's get it on the left. Variable on the left. That's just symmetric property of equality. Okay. So we've got our x equals 7. Again, it's an algebraic, so let's go ahead and test it. So here we say 2 times 7 is 14, so this is 19, plus 42 minus 15 equals 46. So this is 61 minus 15 equals 46, and 61, yep, that is 46. So my check is good, and I'm relatively confident in having the right answer. I don't know if I have time for one more before we just split this up and go to the next video. Let's see how long the next one's going to be. Let's see if we can bust on through it here. Actually, we'll stop here. I'll come back and we'll start number 11.